All right, we're at number 20. I'm going to write down what's given in number 20. And then I'm going to answer. So the first one is take that, what was given, and then what's g at the square root of x? Just a plug-in question. So plug in root x for x. And so what we did is instead of x, it's the square root of x. Everything else, that would be the general term. You could simplify this. Square root of x squared is just x. Square root of x forward to x squared and so on. So you could simplify this. The square root and the 2 simplifies, so just be x to the n. Easy peasy. 21, what's the derivative of this? Well, the derivative of 1 is 0. The derivative here, take the exponent, is negative 2x over 2 prime. The next one would be 4x cubed over 4 prime. The next one, minus 6x to the 5th over 6 prime, and so on. And then what would the general term be? So if I simplified this, 2 factorial is 2 times 1, so the 2's cross out. That's just negative x. Here the 4's divide out, so I have 3 factorial. Here the 6's cross out, so I have 5 factorial when I cross out the 6. See, 4 factorial is 4 times 3 times 2 times 1. So the 4 and the 4 cross out, so what you're left with is 3 times 2 times 1, which is 3 factorial. But by doing this, I see a pattern, and I see what's happening here. And then I can write down the general term of what's happening. So it alternates signs. The exponent is odd. So if I double it, so it goes by 2's, odd. So if I go 2n, that would be even. 2n subtract 1 makes the exponent odd. And if I look at the denominator, same thing, odd. 2n subtract 1 factorial. See how they match the exponent and the factorial number? And there it is. 22, integrate from 0 to x, g at t, dt. So I'm going to integrate. So integrate 1 is x, and then add 1 to the exponent and divide. Add 1 to the exponent and divide. You're going to see what happens. Add 1 to the exponent and divide by that exponent. And so if I simplify this, I want you to understand that 3 times 2 times 1, this is just 3 factorial. 5 times 4 factorial is 5 times 4 times 3 times 2 times 1. I hope you see the pattern. So what's happening, it alternates signs. Again, it's going to be 2n minus 1, or 2n plus 1. Sure. If I plug in 1, you have to be that, right? And then you have 1 factorial 3 and so on. So if I plug in, it starts at, it works. So the first term, the second term, the third term, and it matches, right? Perfect. All right, 23. It says, use what was in example number 9. So if I go back to number 9, if you go back to number 9, this as a series is x minus 1 subtract x minus 1 squared over 2 plus, in alternate signs, x minus 1 squared over, or cubed, over 3, x minus 1 to the 4th over 4. So you can go back to example 9 and see this pattern. If I plug 1 into this series, well, what's 1 take away 1? What's 1 take away 1? What's 1 take away 1? So you could see that f at 1 does equal 0, which is what it is, right? Ln 1 does equal 0. We're showing it as a series that does match. All right, now we're going to do some review questions. And the question is, does this converge or diverge? This is a geometric series. The ratio is e over pi. And the question is that less than 1? So e is about 2.7. This is about 3.1. Just as an estimate, you can see that the numerator is smaller than the denominator. So this is less than 1, so therefore it converges. By the geometric series test, that the ratio, the absolute value of this is less than 1. That's what it means if it converges. 25, similar. Does this one converge or diverge? Look at the ratio. So the absolute value of that, is that less than 1? And the answer is it's greater than 1. So pi, that's like 3 over 2.7. So the numerator's bigger now. So that means it's bigger than 1. So therefore it diverges. 26. Be careful. This is a series. If it was a sequence, this would converge. But a series, if I write this as a limit, power over power, it's 2. For this to converge, this has to converge to 0. If the series converges, this would converge to 0. So this diverges by the nth term test. 27. Again, if I write this as a limit, do you see the top is more powerful than the bottom? So where is that going? If the top is more powerful, right? So this definitely diverges. Again, this is the nth term test. If it does converge, then this would have to equal 0 for a series. And then there may be other tests to see if it really does converge. But this is a test for divergence. So if it doesn't converge to 0, then it completely diverges. If it does have an answer of 0, then it might converge. Turn the page, 28. Determine the following. Now these are sequences. So because they're sequences, it's different. So a sequence, if it converges to a number, that's the answer. So for this one, the right-hand behavior is 2. It converges. 29. Okay, we do that. Just converges. So it's a sequence, it's different. The limit as n approaches e to the n. Well, what's the right-hand behavior of e? It's going up, right? Forever. So this one diverges. It doesn't converge to an answer. Number 30. Determine whether the sequences are monotonic or not. So for 4 plus 1 over n, if I wrote down the first terms, you would see what's happening. So if I plug in 1, the answer is 5. If I plug in 2, it's 4.5, 4 1/3. You can see what's happening. So this is monotonic because it is decreasing. Is it bounded? So as this goes to infinity, the limit as n goes to infinity, know that this converges to 0, so 4 plus 0 is 4. So this is bounded between what two numbers? So it's bounded between 5 and 4. So in other words, it can be equal to 5, right? And it's going to be bigger than 4. So all the numbers are between 5 and 4. That means it's bounded and monotonic. Number 32, 31. So the top is more powerful, so it's unbounded. And does this just go in one direction in terms of when I plug in 1, 2, 3, 4, 5, 6, 7? So the answer is it's not monotonic either. What happens here is at the beginning, the denominator is more powerful, and then as numbers get plugged in more and more and more. So if you plugged in 1, you get 1 over e. But if you plugged in 10, now 10 factorial is bigger than e to the 10. So at first, the denominator is bigger, and then it switches, and the numerator is bigger as it goes on. So that means it's not monotonic, and it's definitely unbounded. The numerator is more powerful, so it's going to infinity. All right, some real simple ones to practice here. So way back review question. If I look here, the hook comes from inside the parentheses. That's 3t squared, so we need a 1/3. So it's 1/3. The integration for tangent is ln. I think it's negative ln, right? Double check. What number is this? 32. 33. Did I skip 32? I skipped 32. This is 33. Let me just finish 33 then. Yeah, it's negative ln cosine. All right, so it's negative ln cosine. Been a while, right? Plus c. Let me go back. The integration of cotangent is positive ln sine. If you want to remember it, you'll practice it, and you will remember it. 32. Evaluate 0 to 1 of this. All right, so this is in the form of arc sine. So I'm going to change the way this looks by factoring out a negative, and I have x squared plus 2x. When I factor out a negative, now I can complete the square, divide it by 2 and square it. So it's 1 that completes the square, and that's really negative 1. So I'm going to add 1 so it stays the same, because negative 1 plus 1 means it stays the same. But now I can combine like terms, complete the square, and finish it. Joseph, can I call you back in like 5 minutes? Perfect. Bye. All right, that was my friend Joseph next door. So 3 plus 1 is 4, and then x plus 1 squared. We're now at a situation where we can say u is x plus 1. The derivative of u is just 1 dx. And a is the square root of 4, which is 2. So this is arc sine u over a from 0 to 1. And then we're going to plug in 1 first. 1 plus 1 is 2. 2 divided by 2. Then we're going to plug in 0. So the y-coordinate, or the angle that gives you 1, is pi over 2. The angle that gives you 0 is 0. So this answer is pi over 2. Oh, I did this wrong. 0 plus 1 is 1, and this is actually 1/2. Ha. So what angle gives you 1/2 is pi over 6. And then you want to make it simple. It's 6 take away 2, which is 4 pi over 6, which is 2 pi over 3. It's 6 take away 2, which is 4 pi over 6, which is what, 3 pi, 2 pi over 3, and it's done. It's 2 pi over 6. I can't do combine. It's 2 pi over 6, which is pi over 3. All right, I'm going to get there. All right, number 34. All right, integrate this. First step, take the derivative first. So the derivative of this is 2x. It's perfect. It's a logarithm. Done. Just takes practice. 35. First step. It could be other things like arctangent, but it's the first step. 35. Similar, but the derivative does not match. So this is going to be arctangent. So u is the square root of x squared. Du is the derivative of x. And then a is the square root of 9, which is 3. So the numerator should be 1 dx. And then in front would be a 2. So it starts with 2. And then for arctangent, it's 1 over a. And then it's u over a. And then plus c. Number 36. E to the 2y minus 1 squared over e to the y. We're going to FOIL this. So the numerator I'm going to expand. So e to the 2y minus 1, e to the 2y minus 1. So multiply and add the exponents. So I have e to the 4y, this is 2, minus 2e to the 2y, plus 1. And then just simplify it by doing fractions. So when you divide, subtract. Divide, subtract. So 2 take away 1 is 1y. Oops. And then divide, that's just going to be e to the negative y. And then integrate each one. So this, the hook is 3, so it needs a 1/3. And then copy. Here, there's no hook, so it's just that. Copy. Here, the hook is negative. And then plus c. Perfect. 37. Almost there. For 37, I'm going to write it as 1 over x. And then ln x to the negative 1/2. The hook is there. So it's just ln x, add 1, and then the reciprocal plus c. 38. 2 left. E to the x plus e to the negative x, e to the x minus e to the negative x. The derivative of the bottom, the derivative of e to the x is e to the x. The derivative of e to the negative x is e to the negative with a hook that makes it positive. This is the hook. So the answer is ln e to the x minus e to the negative x plus c. 39, last one. You have a choice here. If you do a u substitution, this is what it would look like. You could also do integration by parts, but I think it's good to practice this one too. Add 1, take the derivative. So we're integrating x, then would be u plus 1 squared. This would be times u to the 1/3. I would then expand this. Is it not squared? It's not squared. Ha! It's not squared. So I don't need to expand it. So instead, I just need to distribute. So u to the 1/3 times u, you add the exponents. And then 1 times that. And now we're finally ready to integrate it. Now we can also change the bounds. So u is x minus 1. So 2 minus 1 is 1. So we're using this. Plug in 2. And then plug in the lower bound, 1. And 1 take away 1 is 0. So now the bounds are changed. So now I don't need to go back to x. So now I can plug in 1. Subtract, plug in 0. And then I get my answer. And I think the answer is Oh, wait a second, I didn't integrate this yet. Ha. So when I integrate it, I add 1 to the exponent. I did add 1 to the exponent. I didn't do the divide by. That's 3/4. And then divide by, that's 3. So we have 3/4. 1 to the 4/3 plus 3, 1 to the 1/3 minus 0 when you plug in 0. So it ends up being ends up being 3/4 plus 3. All right, all good. That was messy. I got wound down here. All right, Mr. G Math over and out. I'm so proud of you for finishing your work. Until next time.